All right, here we are in my garage again. Okay, we're going to talk about section 8.9, part 1. So worksheet 8.9, part 1, problem 1. All right, I believe we looked at this problem in the 8.8 worksheet, but just to refresh our memory about what's going on here. So I'll just write write out what S does on the board here. Okay. So the initial case gives us lambda, the empty string, and A in S. Okay. Now we apply the recursive rule once to both of these. So recursive rule 1 gives us, let's see, so this is our xb, so we get lambda b. That's recursive rule 1. Recursive rule 1 applied to A gives you ab. Okay, recursive rule 2 applied to lambda, let's see, that gives you lambda ba. Now, remember lambda is the empty string, so that just gives you a b and a ba there. Right, recursive rule 1, x, that's our x. Then recursive rule 1 says you put x with b, okay. You put x with ba, all right. Here we put x with b, and recursive rule 2 gives us a with ba. All right, then each of these again, we'll apply both of the recursive rules again. We got recursive rule 1, recursive rule 2. Okay, recursive rule 1. What does recursive rule 1 do? It says put x, whatever it is, with the b. So we got bb. Here we've got put it with the ba, so you got b, ba. Here we've got ba, you put it with a b, so you got ba, b. And you got ba, ba. Put it with a ba, yeah, and then here we put it with a b, so we've got a, b, b, and here we've got a, b with a ba. Yeah, ABBA. All right, yeah. Okay, put this one a, b, and a, b, a. That's our x. It goes with a, b, a. Okay. All right, and then we just keep doing this forever and ever and ever. One thing you may notice, right, is this is the thing where I was overemphasizing the, hey, what do I notice? I notice that that none of these strings that I've created here, none of these strings I've created, not there, does not have 2 or more consecutive A's, right? There's not 2 or more consecutive A's. Right, if you look at all those strings that I've created here, there's not 2 or more consecutive A's. I know that's kind of a silly thing to observe, but we're just learning how to go about this sort of thing. Okay, so now is the time to turn off your computer, go do problem, or turn off this video, go do problem 1 on 8.9 part 1, and then come back, and I'll go over the answers right now. Okay, so 8.9, so problem 1, we got 8.9 part 1, problem 1. Problem 1a says, what must be proved in order to prove the base case? Okay, so proof by structural induction. So the property that we're trying to prove, P of x, is that x does not have 2 or more does not have two or more consecutive a's. Now we're going to try and prove p of x is true for all x in S, right? And there's many more x's in S, right? Then this would create BBB and BBBA, right? And this would, and so on and so forth, right? So many more, but here we can see that a property arising, this property is that x does not have two or more consecutive a's. All right, so part A, we want to say, what do we prove? What must be proved in order to prove the base case? So the base case, we have to prove that everything's true for the initial case. So here we need to prove that lambda and A do not have two or more consecutive a's. All right, and you can see that's pretty clear, right? Lambda, the empty string, doesn't have any a's in it, so it definitely doesn't have two or more consecutive a's. And a is just one a, right? So if there's just one a there, there's not two or more consecutive a's, right? There's just one consecutive a. Okay, so you can see that's true there. All right. Okay, now part B. Oops. Part B, we got recursive rule 1. Okay, so y is equal to xb. Now our assumption here is that, so the assumption is that p of x is true. Otherwise known, our assumption is p of x. X does not have two or more consecutive a's. What are we trying to show? P of y. We want to show that y does not have two or more consecutive a's. All right. Part C, recursive rule 2, y equals x BA. Again, our assumption is P of x, that x does not have two or more consecutive a's. And we want to show that y will not have two or more consecutive a's. Right, do you see why that's true? Do you see, like, let's say that we actually did want to prove it instead of just the problem only asked you to talk about what you actually, what your assumption is and what you want to prove, right? So, but think about how we would actually prove this, okay? If our assumption is that x does not have two or more consecutive a's, then adding a b to the end of something that doesn't have two or more consecutive a's doesn't add any consecutive a's, right? Here, x does not have two or more consecutive a's. Adding a BA doesn't put an A next to, can't possibly put an A next to another A, right? If this thing doesn't have two or more consecutive a's, then it's putting on a BA on the end isn't going to possibly put another, an A next to an A, because this A is next to a B, right? So in that case, P of y is also true. Okay, and that's how a proof by structural induction works.